All right. We talked about mean, we talked about standard deviation. Let's talk now about covariance. The context in which I'm going to introduce the concept of covariance is in terms of sums of random variables. So let's consider sums of random variables, two different random variables. Okay. So suppose we have two different random variables. Defined on the same probability space. So they're both random variables in the same sample space. We're going to define S to be their sum. What we have is the mean of S. So the expectation. So let's express expectation of X is mu of X. Expectation of Y is mu of Y. So on. Mu of S is equal to, the mean of S is just the sum of the means. We know that. S minus the mean of S. Well, that's by definition X plus Y minus the mean of X plus Y, which is the sum of the two. So we can rearrange. We get X minus mu Y plus Y minus mu Y. And if we square this, we get X minus mu X, I'm sorry. X minus mu X squared plus 2 X minus mu X, Y minus mu Y plus Y minus mu Y squared. So the expectation of, so the variance of S, the variance of the sum in this case, it's the expectation of of these three terms, the sum of the expectation of these three terms. This is these are both variances, so we get variance of X plus variance of Y. I'm rearranging the order a little bit here. And then this term here, the expectation of this term is what we define as the covariance, plus 2 times the covariance of X and Y. So when we have two random variables, we don't take the expectation of a pair of random variables. That's not well defined yet, or we haven't defined it. But we can define this quantity called the covariance, which is some measurement of how X and Y vary together. This will be something that comes up more towards the end of the course or later in the course when we talk about joint distributions, pairs of random variables, and so on. Expectation, and there is covariance is actually very similar to variance in some ways, as we'll see. And there is a computing formula for it. It's the expectation of X times Y minus the product of the expectations. So expectation of X times expectation. This is the covariance of X and Y. So it's natural to ask the question, why does the variance of X plus Y involve more than variance of X and variance of Y? Right, so in what way, what else could be contributing to the variance of this quantity than the variance of the two variables that are involved in the quantity? And so that's what we're going to come back with next, and give some interpretation for how that works.